Hello everyone, on this podcast we're going to look at these objectives. Compose the name of simple ionic compounds that are made of a metal and a nonmetal. Compose the name of ionic compounds that have polyatomic ions in them. And compose the name of ionic compounds when the metal can form more than one ion. First, a quick review. Ionic bonds are formed between ions. Metals tend to lose electrons and become cations. That means they are positive ions. Nonmetals tend to gain electrons and become anions, negative ions. Now, once formed, these ions, they attract each other. Let's take a look at objective 1. Compose the name of simple ionic compounds made of metal and nonmetals. Periodic table is right here. I'm going to move it on over. Let's take a look at her. I want to confirm for you that in fact metals become, let's get a little bit closer, there we go. Here is a metal right here, and in fact it becomes a positive ion, a cation, beryllium +2, calcium again becomes positive ion. This will become important later. Here we have iron. Iron becomes a +2 typically, but at times it could become +3. Our third objective will touch on that. Also, copper is a good example, +1 or +2. Again, our third objective will touch on that. Okay, so let's try this out. Let me compose some simple formulas for you. So Li perhaps, Li3N. Okay, so what are these? Well, we do have a resource that will help us out, and that would be our table S. Take a look here. Table S helps us know the names. Okay, here we have lithium. Where is my, there we go. Lithium. And N is, where are you? N, there you are, nitrogen. So our first one would be named lithium. Well, the second element is nitrogen. We have to alter its name and make it nitride. So in essence what we do is we chop off the end, we add IDE. Do another example. Let's get this out of the way. Let's grab a pen. Okay, let's just say magnesium and oxygen together. That is the correct ratio. Magnesium is a +2, oxygen is a -2, so it's a 1-to-1 ratio. This one is called magnesium wait for it, ide. Okay, so far so good. Let's do another. Grab the periodic table so we can build a compound. And let's do one with calcium, and let's just say phosphorus. Let's get this out of the way. Okay, calcium, Ca, it's A2+. Phosphorus, it's A3-. It's 3 of those, 2 of those, doing the crisscross. What do we name this? We name it calcium phosphide. Okay. Simple ionic compounds. One metal, one nonmetal, one metal, one nonmetal, one metal, one nonmetal. The metals, you do not alter the name. The nonmetals, slice off the end, add IDE. Now to our second objective. Compose the name of ionic compounds that have polyatomic ions. Taking a closer look at polyatomic ions, please notice that they are in fact ions. A charge spread across, well, the entire compound here. H3O is a compound that is sharing a positive charge throughout. NO2 is a compound. nitrite that is sharing the negative charge throughout, and so forth. Here's carbonate, CO3 2 minus. Let's put together a few compounds and name them. Okay, stick that guy over there. Let's just say, for instance, let's go back to lithium. Lithium is a +1. Let's grab here a polyatomic ion that is a -1 to make it fairly simple. And let's go ahead and grab this guy right over here. This one, nitrite. So NO2, it's a -1. That is lithium, don't change the word at all, nitrite. Let's take another one. Let's use calcium this time, which is a +2. Let's use the nitrite again, NO2 minus, crisscross them, and we will realize that we need 2 nitrites in order to balance. This one is called calcium nitrite. Take an example where we have a positive polyatomic ion first. We have H3O plus, and let's balance that off with, no, let's not do oxygen. Let's do nitrogen. Nitrogen is a 3 minus. We crisscross those. We'll need 3 hydroniums for every 1 nitrogen. And this one is called hydronium nitride. We would alter the name of the nonmetal because it is in the second position. Alright, what else can we do with this? Oh, one other thing we can do is, what if we have a positive polyatomic ion mixed with a negative polyatomic ion? Let's just say, for instance, ammonium. If we have NH4, that's a positive. Let's choose one that has a 2. Let's choose this one, carbonate. CrO4 2 minus. Do the crisscross so that we get the formula correct. And we have 2 ammoniums for every 1 chromate. Its name is ammonium, there we go, ammonium chromate. Hope this one was helpful. Here we go on to our last objective. Now, we need to compose the name of ionic compounds when the metal can form more than 1 ion. What I mean by that is the following. Let's just take 2 examples. Iron. Iron is Fe, and it could have a +2 or a +3. Most commonly the +2 because it would like to lose these 2 last valence electrons. Copper is another example I would like to use, a +1 or a +2. More commonly a +1 because it would like to lose that valence electron. Let's go to the next screen, take a look at them, and figure it out. Okay, everyone, we're in the home stretch. I just want to change the color of the pen. There we go. Now this is iron, and that is oxygen. Typically, we would call that iron oxide, similar to the first objective. But let's take a deeper look at this. Oxygen is a -2. We have a 1-to-1 ratio of this. So to balance out, iron better be a 2+. But remember, let me make a plus sign. There we go. But remember, there are 2 different oxidation choices. This one is the 2. So we need to do what's called the stock system. We will put a Roman numeral 2 after the iron to identify which oxidation number we used. Now, let's go ahead and take a look at this next one. And I'll show you a nice little trick here. Okay. There we go, red pen. We could reverse the crisscross method. We could take this 3 and reverse it. and that would mean that this up here would be a +3. Reverse that, 2 minus, suggesting that this one is iron. Wait for it. 3 oxide. Now it would be nice if you would pause the video and try these next two yourself. Alright, let me show you how they work. Okay, well remember oxygen is a 2 minus. If oxygen is a 2 minus and we needed 2 coppers to bond with it, this copper must be, oh, and also there is an implied 1 here, this must be a +1. So this would be copper 1 oxide, and this one here 2 minus, therefore this must be a 2 plus. It's a 1-to-1 ratio. This one is copper 2 oxide. Well, I hope this clarified some things, and let me also introduce you to your next chemistry teacher. Say hello.
Hello.
Come on, say hello.
Hello.
All right. Be well, everyone.